So this lesson deals with the law of conservation of matter, and as far as chemists are concerned, the biggest contribution of the law of conservation of matter is to a balanced equation. So let's take a look at the law first. You can see it there on your organizer. By the way, this organizer is page 503 in your binder. If you don't have that out, please pause the video and get it out. So the law of conservation of matter says that matter can neither be created nor destroyed. It can only be rearranged. And so we see that manifest itself in a balanced chemical reaction by having the same number of atoms, so you can see this idea here, the same number of atoms on both sides of the equation. So if 5 hydrogens goes into a reaction, 5 hydrogens have to come out of the reaction. You can't have, there is no magic in chemistry, even though it seems that way sometimes. You have to account for all the matter that you have going in and coming out. So you can keep a tally, and I'm going to do it on paper for this, but if you can move out of doing a tally on paper, that's fine. You can keep it in your head if you want. But at some point you have to keep a tally and figure out how many hydrogens and oxygens and whatever else you have. All right, so let's take a look at some of the rules for balancing. The first one is always true. Once you have your formulas written correctly, so that's what you did in Unit 4A, you learned how to write your formulas. Once you have your formulas written correctly, you don't change those. The only way to balance an equation is by adding coefficients, so numbers out in front. You never are going to change subscripts once you've written that chemical formula right. So, for example, our first equation, I'm going to try and zoom this in a little bit since we don't need to see so much of the paper. So our first equation, very simple. H2 plus O2 yields H2O. So what I'm going to do is kind of put a divider between the equation sides. So the left side has to have the same number of atoms as the right side. So if I keep a tally, I know that I have 2 hydrogens on the left, and I have 2 oxygens on the left. On the right side, I have 2 hydrogens, but I have only 1 oxygen. So something's going to have to happen. I've suddenly made an oxygen disappear. In chemistry, that doesn't happen. The oxygen has to be somewhere. So we have to balance the equation to show that we've maintained the law of conservation of matter. So in order to do that, I'm going to add coefficients. I'm going to put a 2 out in front of the water on the right side of the equation, on the product side rather. And so now that changes my number of oxygens to 2. But if you recount, what I've also done is I've changed the number of hydrogens. I now have 2 times 2, or 4 hydrogens. So I've balanced oxygens, but I've unbalanced the hydrogens. So now I have to go back and rebalance. 4 on the right, I need 4 on the left. So in order to get a 4, I can put a 2 out in front of that and have 4 hydrogens. I don't have to do anything with the O2. So now you can see the coefficients of my balanced equation are 2 hydrogens plus 1 oxygen yields 2 H2Os. And again, remember that these numbers out in front typically mean moles. So 2 moles of hydrogen plus 1 mole of oxygen yields 2 moles of water. So this, using coefficients to balance, is really the only rule that you have to follow. The rest of these are helpful hints, but they're not ones that you have to do every time. They are things that will help you in certain cases, but it's not something that has to occur. So this next rule, it's often helpful to save hydrogens and especially oxygens for last. Because if you look at equations, a lot of times you see oxygens everywhere. So take a look. I've got oxygen, oxygen, oxygen in all of the molecules. If I save those for the end, I'm going to be able to balance better or more easily. So once again, I'm going to tally. So hydrogens, I've got 3. Phosphorus, I have 1. Oxygen, I have 4. And then on the product side, hydrogens, I have 2. Phosphorus, I have 2. And oxygens, I have 5 plus 1, so I have 6. So what am I going to do? Save hydrogens and especially oxygens for last. Let's start with phosphorus. So I've got 2 on the product side. To get 2 on the reactant side, I'm going to change the coefficient to a 2 there. But now that means I've disrupted all the other numbers. So 2 times 3 is 6 hydrogens. 2 times 4 is now 8 oxygens. Okay, so let's go to hydrogens next because my phosphorus are balanced. So 6 hydrogens here, only 2 here. So I can put a 3 out in front because 3 times 2 is 6. So I get 6 hydrogens on the product side. What have I done to the oxygens though? Now I have to recount oxygens. So I have 5 here plus another 3 there. Gives me 8 oxygens on the product side. And hey, look at that. 8 oxygens on the reactant side. I didn't have to do anything for oxygen in order to get it to balance because I saved them for the end. So that's one hint that becomes useful. Save oxygens and see if they work themselves out. Next hint, again, doesn't have to be followed, but is useful at times. Find a lowest common factor. So once again, we're going to tally everything up first. I've got 1 RB, I've got 1 Cl, and I've got 3 oxygens. 1 RB, 1 Cl, and only 2 oxygens on this side. So everything's balanced except for oxygen. 3 on one side, 2 on the other. If I can get 6 on both sides, they will balance out. So I can get a 6 by putting a 2 in front of RB ClO3. Gives me 6 oxygens, but remember it also changes my RBs and my Cls. In order to get 6 oxygens on the product side, I'm going to put a 3 out in front there. Gives me my 6 oxygens. So now oxygens are balanced, but remember I misbalanced the RB and the Cl. So to get that balance back together, I'm going to put a 2 in front of that. That gives me 2. Again, you don't have to keep this physical tally, but it is quite useful sometimes, especially when you're just learning how to do it. All right, next one is when you're dealing with reactions involving ionic compounds. It is quite useful if you see a polyatomic ion on both sides, for example, nitrate here, nitrate here. Instead of breaking that up into nitrogens and oxygens, keep those together. So what I'm going to do is I'm going to count how many strontiums do I have? 1. How many nitrates do I have? 2. How many aluminums do I have? 2. And how many sulfates do I have? 3 on my reactant side. If I keep those together, that's going to make balancing a little bit easier. So on the product side then, strontium I've got 1. I'm going to keep it in the same order so I don't get confused. So nitrate I now have 3. Aluminums I have just 1. And then sulfate I have just 1. So how do I get things balanced out? It doesn't really matter where you start. If we start with the nitrates, because strontium's already balanced, 2 on one side, 3 on the other, common multiple again, so I can kind of refer back up to the rule number 3. If I can get 6 on both sides, nitrates will balance. So let's do that. To get 6 nitrates, I need a 3 there. So that gives me 6, but then I have got to readjust my strontiums. To get 6 nitrates over here, I need a 2 out in front of the aluminum nitrate. That gives me 6, and then aluminums are 2. And look, by doing that, my aluminums have now balanced out, so that's convenient. All right, so let's go back to strontium. 3 strontiums on the left, only 1 on the right. If I put a 3 out in front here, I get 3 strontiums, but it also changed my phosphates, or my sulfates rather. I get 3 sulfates, and look at that, it balances out. So if you have your formulas written properly and keep your polyatomic ions together, doing something that looks really complicated with these ionic reactions actually can be pretty simple to work out. But you just got to remember to keep them together. All right, next rule, I'm going to zoom out a little bit. Next rule is the idea of if you have to use a half or a fraction or something in order to balance the equation. So if we take a look first at this one, to balance this, and again we're looking at C4H10, so let me zoom in. We've got, there we go, I'll focus it. We've got 4 carbons, we've got 10 hydrogens, and we've got 2 oxygens on the reactant side. we have only 1 carbon, only 2 hydrogens, and 3 oxygens on the product side. So now this is the case where you definitely want to save oxygens for last. So 4 carbons, 1 carbon, so I can put a 4 there. Not the best marker. Let's recount our oxygens. So now I have 8, 9 oxygens, but my carbons are now balanced. Then I can go on and do the hydrogens. I've got 10 hydrogens, 10 hydrogens on the left, only 2 on the right. If I put a 5 in front of the water, I can get now 10 hydrogens. But now recount your oxygens as well. 8 here, 5 here gives me 13. In order to get, so everything's balanced except for oxygen. In order to get 13 oxygens on this side, I would need to put a 6.5 there, because that would give me 13. But you can't, you usually don't see a half in a balanced equation. So we're going to make this, we're going to take this whole reaction and multiply it by 2, because then that'll get rid of the half. So what are my coefficients going to be? 2 C4H10s. 2 times 6.5 is 13 oxygens. 2 times 4 CO2s is 8 CO2s. And 2 times 10 waters, and 5 waters is now 10 waters. So my true coefficients should be 2, 13, 8, and 10. So that one, you don't see that very often, but there's one kind of reaction that's called a combustion reaction that you will sometimes see that with. So that becomes quite useful. All right, the last one seems like, this is kind of years of my experience. When it doesn't look like you have a logical starting point, just try and get even numbers of atoms. And so if you take a look at what you have here, we've got 1 sodium, we've got 2 hydrogens, we've got 1 oxygen on the reactant side, 1 sodium, 3 hydrogens, and 1 oxygen on the product side. So everything balances except hydrogen. So you might think, well, common multiple. The only problem is we've got hydrogen in 3 places. So my suggestion is this. I got evens here, I've got evens here, but I have an odd here. So in order to make this even, I'm just going to put a 2 out in front of here. Okay, so a lot of times evens are easy to work with than odds. So if I put a 2 out in front of there, that means now I have 4 hydrogens. So how do I get 4 hydrogens on the other side? Well, I can put a 2 in front of the water, 4 hydrogens. But if you think about what I've done by putting the 2 out in front there, I now also have 2 sodiums and 2 oxygens on the product side. But if you take notice, by putting the 4 out in front of the water, I also have doubled my oxygen. So I'm still okay. And the only thing I need to do in order to get sodium to balance is to put a 2 out in front of it. So by doubling that odd number, I've been able to balance it pretty easily. And it might not happen beautifully the first time for you, but that's just a hint that will help you. All right, so we are running out of time here. So we're through all the examples, but on the back side of this organizer, you will see that there are practice problems to do that I will go through on the next video and share the answers with you. So try these 5 before you go to problem set number 1, just to make sure, because I'm going to go through the answers for these. Okay? So pause this and go balance, or stop it, I guess.